Hello and welcome to this video validating a 5G NR transmitter using Keysight's PathWave system design software, also known as SystemVue, with Keysight's Vector Signal Analysis software, also known as 89600 VSA. These two software products are seamlessly integrated, as we will see in this demo. For the demo, we will use the NR Downlink test model example workspace to simulate a base station RF transmitter, and we will use the 89600 VSA software to visualize and analyze in detail the transmitted signal. Test models are fixed configurations defined by 3GPP for base station transmitter conformance testing, and this example workspace is using test model 1.1 for FR1. I'm increasing the oversampling ratio to give me enough measurement bandwidth for adjacent channel power and spectral emission mask measurements. And there's a low-pass filter for spectrum shaping with the number of taps that can be turned on or off, and it is on for this example. You can see the VSA sync here. Let's go ahead and enable that and hit simulate. The 89600 VSA software opens up, and we can see the 5G NR spectrum. We're going to start with modulation analysis for EVM type measurement. Then we'll move on to ACLR and spectral emission mask or SEM measurement. Quickly setting up the test model signal. The bandwidth is 50 megahertz. The duplex is FDD. It's 15 kilohertz numerology, and it's test model 1.1. And let's hit apply and close the window. As you can see, VSA uses a multicolor coding scheme to make it easy to visually identify symbols, subcarriers, and data results within the various traces. This makes cross-trace data comparisons and analysis easier to accomplish. Different colors are assigned for different channel types as seen in trace F. A user can also customize and reassign trace colors if needed. And there are two payload channels and one control or PDCCH channel, which is in yellow, and the other graphical traces, such as the detected allocation time trace, clearly shows those colors. The detected allocations time shows the resource allocation in frequency and time grid for each individual channel. In this case, the 50 megahertz bandwidth test model 1.1 signal, which is 270 resource blocks wide, are fully occupied by the two payload and one control channel. Trace D is error vector spectrum, EVM in y-axis and subcarrier or resource block in the x-axis. You can see the high EVM and upper and lower edges of the spectrum. In particular, the lower edge of the spectrum has the highest EVM. And for this particular example, it was identified the cause for this high EVM is the spectrum shaping filter. This filter was optimized for the out-of-channel measurement of that, for example, ACP, and not for the in-channel or EVM measurement. And the 3D EVM plot can clearly show us that information. 3D EVM displays EVM versus subcarrier versus symbol, and it is a great visualization tool. You can rotate, zoom, and pan to view a particular element. You can clearly see high EVM for lower subcarriers. You can put a marker anywhere on this trace, and here the peak marker shows 12.6% EVM, and it is on the downlink share channel 1. Summary trace shows all error metrics, the RMS EVM of 0.6%, peak EVM of 12.6%, and other metrics including frequency error, phase error, IQ offset, and etc. Trace A is constellation diagram showing the QPSK for all the different channels. Even though they all use QPSK modulation format, the color coding enables you to see there are multiple channels being analyzed, all using QPSK modulation format. One of the most powerful tools in the 89600 VSA is the coupling of markers across different measurements, traces, and domains. Coupled markers allows you to understand the identity and characteristics of a symbol simultaneously in time, frequency, and error. Place a marker on all graphical traces and couple the markers, and the marker window shows you all the information. Right-click on Trace D and select Peak. The exact symbol associated with this peak EVM can now be understood in terms of time domain, symbol index, frequency domain subcarrier number, channel type, modulation format, IQ magnitude and phase values, and other parameters are shown in this marker window. VSA has various additional traces, such as the 3D power plot, where you can see power versus subcarrier versus symbol, and this becomes very important to visualize if all the channels and signals are transmitted at the expected power levels. You can learn about these different measurements by using the dynamic help system. It allows you to access the help text by following your menu choices and provides detailed information about the measurement, including technical details and references to the 3GPP standard when applicable. You can also lock it to stay fixed on important help topics. Let's now move to the adjacent channel power measurement by adding an ACP measurement. VSA has a 3GPP compliant ACP measurement by using a standard specific preset, which will open a context window to configure the signal. You only need to configure this once. Same signal configuration will apply to the spectral emission mask measurement, as we will see shortly. I have the carrier frequency, bandwidth, and numerology set. This is, again, test model 1.1 signal. As you can see, all the test models are supported by the VSA. It's an FDD duplex. And once you have the right settings, you can go ahead and apply the context to the ACP measurement. The measurement is configured accordingly as defined by 3GPP. For this demo, it passes the 3GPP conformance test. The frequency offsets, the integration bandwidth, the pass-fail limits, etc., all of those are configured automatically based on the 3GPP definition. The user does not need to be familiar with the 3GPP conformance test specifications. Next, I'm going to add spectral emission mask measurement, and I'll apply the exact same configuration to this measurement. With just a single click, I have the spectral emission mask measurement per 3GPP's requirement. The offsets and limits are set automatically, again, based on 3GPP's requirement, and the test passes. As we just saw, the PathWave system design software connects seamlessly with the 89600 VSA software for an in-depth 5G modulation analysis plus 3GPP compliant ACLR and spectral emission mask measurements with the pass-fail results per the standard. To learn more and to download a free trial, visit us at these websites.